If your Dell breaks, please do not send it here because I suck at repairing these boards. Especially Dell boards. Okay. So, we should be back. I forgot my charger and I cannot troubleshoot motherboard without our charger. So, if you guys remember, oh, last week or something, we had a Dell board that we knocked off capacitor and it worked. Well, I put that board in the case and it started beeping. So on that board, that computer's getting a new motherboard. So I had another board here from a long time ago. This one is the same exact model board. This one we get our 3.3 volt and 5 volt rails, but we get no power up. This was liquid damage. We had some liquid near the CPU. It does not power up. But the most important thing about this is we have a donor board. We have the old one, so we're going to try and fix this. So another quick thing, new microscope. This is a SM3 NTP something. I don't know. It's what everyone uses, 3 to 45x or 7 to 45x, something like that. We're getting a camera next week. I ordered the camera last night. It should be here either tomorrow or Tuesday because Monday's a holiday. So we should get our camera, and then we could do some real live streams, you know, and have a decent channel here for once. So first thing I want to do is plug this in and let's double check and see if it powers on after sitting here for a few months. Never know. And if we look at the block diagram that I have up on the screen, we see that we have two always present rails, and that's our 3.3 volt and 5 volt rails. Those are going to show up on PL201, which is going to be at these two coils. You can't really see it, the bottom of the board. So let's measure those. Those are probably going to be present. This had liquid damage, heavy liquid damage to the 5 volt rail circuit. But I was able to restore the 5 volt rails, but it still does not work properly. So let's measure our 5 volt rails. I'm sorry you guys can't see. Wait until next week and then you will be able to see. Got a new mat today also. I'll pull this out. Main thing I like about this microscope is if I need to see something, I can pull it out and not, you know, like my old one, I couldn't do this on. So voltage, let's check. We have our 5 volt rail. We have our 3 volt rail, 3.42 volts. That's perfect. Probably missing 1.35 or 1.05. Probably. Let's see. So we have, looks like we have these, right? So we're good here. We have our always present rail. Looks like we need our 1.8 volts. Let's go down this. Let's go to right here. Since this is going to be in suspend state, right? I don't really know too much about Dells, but I think we need a prompt to power on before we do anything else. So let's prompt this board to power on before we go any further, because if we don't prompt it to power on, we're probably going to get 0 on all of those rails. So let's see if I can do this. If I remember correctly, this was missing I don't know, it's been months. This has been here for months. Okay, where's our power So what I'm gonna do is I'm gonna plug this in. I'm gonna prompt it to power on. Since these are not going to, these boards do not start up on their own. Not like MacBooks. So let's prompt this to power on. I'm going to have to somehow make this work. And watch, sitting, this one's probably going to work. Okay, we prompted it to power on. We can unplug this now. We have a light, but we're dead. So we have an LED. To get this LED, we need our 3.3 volt and 5 volt rails. So that's expected. That's saying it has power. So let's go through now and let's check our rails. So we need a 1.8 volt rail. Let's have a look. This can be found on page 47. So let's look at page 47. So here it looks like our 1.8. Wait a second here. This is our 5 volt now. Where's our 1.8 volt come from? Gotta look closer at this. So, oh, this is our 5 volt. Where does 1.8 volt come from? I don't see anything where 1.8 volts comes from here. All right, let's just type in. Let's go back to page 56. Actually, you know what? Let's look up the chip number, because that's going to lead us to where this rail is generated, and that's where we're going to want to look. For all I know, I don't know how these Dell boards work, but my guess is there is going to be initiation signals from the PCH. Here we go. So let's see how this works. So it looks like coming in we have our 3 volt. It's going to go through this thing. And then we're going to get through this chip, which is PU400, and we're going to go through a coil, and we are going to get our 1.8 volt rail. So let's find this. So PJP400 and PU400. We don't have the luxury of a board view, so we got to look on the board. Or an ITE. Yes, it could be the ITE, and I don't want to change that because that is a pain, but if I have to change it, I'll change it. Alright. Let's have a look here. Where's my OBS window? Right here. Let's move this over for right now so you guys can see at least a little bit. Move this thing back. Kind of a pain, but yeah, it's probably not. I think we'll fix this, but let's find where PU400 is, and this is a big board, so I don't want to. Right there, I see it. Okay. So let's see. Need to go push the microscope back some. Too bad you guys couldn't see. So there is our 1.8 volt rail generation, and let's It's going to come out on PL400. So let me find PL400. I'm guessing it's going to be that coil. So it's going to be right here. One lead on ground. We get nothing. It's like we're completely dead now. No. Nope. Okay. So it looks like we have, so I don't have, yeah, that's what I'm checking to see if the pin, if this chip is getting voltage. It does look like we have our voltage right here, right? So we have our 3.3 volt rail, or 3 point whatever it is. We are getting our voltage here now. This signal right here from the PCH, I'm pretty sure this is coming from the PCH. This is going to go onto pin 5. So pin 5 is going to be, so I'm trying to figure this out. The dot is going to be where pin 1 is. It's going to go through a resistor, 402 package resistor. Guessing it's just going to be, this is why I like having a board view. I don't like doing this, but if we must. So we're going to have these 3 pins, I'm pretty sure, are 3.42 volts, right? Then this next one is going to be, I think, ground. Or NC, that's NC. This is a resistor on this last pin right here. There's a resistor right there. Trying to figure out here what is what. So there's, okay, so here's our circuit right here. So we have a cap. This is a 0402 16 volt. Then we have another resistor. So I found our circuit for the PCH and we're missing this. We have 0 here now. I don't know here. I don't know if this is a 0, if this is an L line, meaning it's enabled when it's low, or if this is if there's voltage here. So now that I kind of figured out, I made a map in my head of the circuit. I know where our resistors are. I know where the signal is coming in. I know the signal is completely dead. So what I'm going to do now is I'm going to get my other board that has a dead PCH. It still powers on, it just beeps. So at least it reaches an SO state. I'm going to measure that on the other motherboard. I'm going to see what I get. And my next step is I'm going to put 1.8 volts there and see if it powers up. Or I'm going to see what the signal is, and I'm going to try and steal this from an SO rail on this board, on the other board, to see if I can make this thing power on. So let me find, this is our PU400, looks the same. I'm going to prompt to power on. Plug this thing in. This is not the right, what cable is this? Micro USB, not even close. Let's plug this in. Let's prompt to turn on. I know there's a BIOS setting on these. So our fan is spinning. Now we're going to measure. If our fan is spinning, we know we have our 1.8 volt rails. We're reaching SO state. I'm interested in what the EN pin voltage on the load on the dead board compared to the one that beeps. That's what I'm thinking. So get organized. No, organization is not something we do here. That's what I'm going to check right now. Hopefully this stays on. Our processor is getting hot, but our fan isn't spinning, so PCH is getting hot. So we should have our 1.8 volt rails if our processor is getting hot. At least that's what I would think. So let's measure. We'll need on ground as usual. We have half of a volt there, and we're not getting half of a volt there. So, I mean, we have a half a volt, and it's cycling. Yes, it looks like we have. Yeah, we have about half of a volt. So, my only guess is, let's try in with the DC power supply and the other one. Let's put voltage there. Let's put a half of a volt there and see if it turns on. But now we need to look. Since that enable signal that's being used is missing. Cords are stuck into my chair. So what do I do? That's what I'm looking for right now, where that comes from. So PU 400. Is this where it's generated? No. Still an input there. Here we go. So, where is it? Still an input. Where does this come from? Come on. Looks like still an input. No out. Wait a second. This looks interesting. Okay, so let's look closer at this. So it looks like we get our 5 volt in, and so we get our 5 volt in. It's gonna come out. Go through a little FET, and that's gonna. Let's see if this doesn't output it. I don't get this. So it looks like this is what does the job right here. Wait, no, it doesn't. That's not right. Here we go. So where is my suspend signal? It's got to be somewhere right here. PM Sleep S4L. This board has that too. Right here. Okay. So suspend comes from this thing, and I think anybody that works on these knows what this thing is. So let's see if PM Sleep S4L is present. But I don't think it would be. So it's coming out of the PCH, of course. Why? Okay. Where was it? I lost it. I can't very well take the PCH off the other board and put it on there. I want to try putting some voltage. This might be very, very stupid, but I'm going to take about 1/2 volt. I'm going to put it on that enable signal, and I'm going to see if we get our 1.8 volt rail. And then I'm going to see if we get our fan spin. So I'm going to prompt to boot, or I'll solder the wires and just do it all at once. One thing I'm concerned about though is my power supply. What happens when it turns on, sometimes it spikes to higher than what it should be, and I don't want to cook anything on the 1.8 volt rail. So I am going to attempt to do this without blowing anything up. So I'm going to put our enable signal first and foremost. I have to solder some smaller wires onto this. I'm going to use red and green, green for ground and red for power, of course. And now my other question is, can I find something with 1/2 volt and steal it and put it there and try and get this thing to work, since I really have nothing to lose? What power supply do I have? It's an X-Tech 38 2200 $100 power supply. It works. It does the job. Hello to the new person that just walked in. I have a mess here. Wires are all tangled up. This is big enough. Let's move these boards out of the way, and I gotta solder wire under my DC power supply. Get a piece of sandpaper just to make my life easier. The coating on this larger, I don't know if it's 26 gauge or whatever it is, it does not burn off easily, even at 840. Got to actually sand it a little bit. I mean, eventually it will burn off, but it's just quicker for me to sand it. Yeah, this is a new scope. The camera should be here next week, sometime after the holiday. Or maybe tomorrow. But I'm not going to be here tomorrow, so. Come on. Why is this thing not melting solder? There we go. This Hakko better not die on me, it's not even that old. That's our power, and let's do our ground. What? Rising star camera? What is that supposed to mean? Hopefully once we get a camera, more people will watch or stay watching. I hope so. I think that's the main thing right now that's limiting the channel, is not having a microscope camera. It really you know, brings things down. We're not getting the best camera in the world, but it's good enough. Here's my Flux. What is the defect? It's broken. It doesn't turn on. Looking like an issue with the process, the PCH. But we're gonna try and force it to turn on. So you guys will be able to see sometime next week. You know, next when we do our streams next, you guys will actually be able to see, and that'll be a plus. So I'm gonna take my board. So what do you think? Should we solder 0.5 volts to the 0.6 volts to the enable pin? Or should we solder 1.8 volts to the main rail? I don't know. I'm thinking more to the enable signal, but you know, that would be my choice. I do not like this. Some electrical tape. What is it? Yeah, this is a Dell. The schematic you're looking at is this PCH. It's on the screen. I usually fix MacBooks, but thought I have a Dell here. Why not stream it? I make a lot less money on Dells, but one thing that I learn, and that's what matters, is that I learn. You know, with Macs, I still learn on Macs, but it's getting to the point where it's, you know, change this, it works, great, out the door, but something new for a change isn't. What model? Hang on, that's hidden. What model scope? It's a SM3 NTP or TNP or something like that. AmScope. Trinocular, semifocal. You know, It's a decent one. I try 0.5. Yeah. Let's do both. Let's see. Gotta set my power supply so it doesn't blow up the rail. So let's set our power supply right now. So usually this is at like 12 volts or 16 volts or some nonsense like that. Turn up our amperage just a little bit. We don't want too much amperage going into our PCH. Volts, 6 volts. Can I even go that low? 5 volts, 4 volts, 3 volts, 2 volts, 0.6 volts. Alright, 0.6 volts is enough. 0.6, the other one was 0.59, so same scope I just bought. No, I paid $410 US shipped for this scope. Yeah, any board is a learning experience. But sometimes something new is good too. I have a fun board we'll be doing on New Year's Eve. It's a 820 3208. Missing PM Sleep S4L. Just to be clear, he tested while hitting the power button. No, I prompted it to power on, then I measured. I can't very well do that with the top case. Where's my solder? You gotta be kidding me. I moved my office around, and this is the first repair I've done. Where did I put my solder? Here it is. I just got this mat today and fully set up the setup, so still finding stuff. But this microscope is so much nicer. Could actually see. Yeah, I know. A oscilloscope would help in this situation. I won't be able to hit that and measure it because one, that's on the other side of the board, and two, the top case is too big for me to, mess around with like that. I really don't think we are. So we're just gonna, if we can get our 1.8 volt rail when we do this, great. And when this was liquid damaged, we did have some corrosion near the PCH, so that's raising some red flags in my head. I'm gonna scrape and solder this to ground. Let me get some. What schematic? What scheme? I think you mean schematic is used to To analyze LA? I don't know. Yes, I do need more hands. Thank you for noticing. If I had 3 hands, this job would be 10 easier, or 4 hands, or 5 hands. Look a little funny, but who cares about that? Okay, there's our ground. We don't want to short anything. Not that 0.5 volts is really going to do anything, but I'd still rather not. So flip it over. Let's hope it does not short anything. I want to turn it down, turn it on. And of course it spiked to 26 volts for a second. Hopefully we're alright. Just want to gently ease this up. Okay, we're at 0.6. Let's go ahead and plug in our charger. Hopefully it does not blow up or do anything crazy, and I need my DCM board. That's over here. Hold the meter. Yeah, no, I'm not doing that. I'm not doing that. I don't get paid enough to do that. First of the year I will, but not right now. I think we're alright. Let's plug it in. Get smoke, fire, light, nothing. Let's get our top case. Give our light. Nothing. Nothing at all. Dead. Let's measure now. Do we have 0.6 volts there? Is it being held to ground by something? If it is being held to ground by something, we have probably a dead PCH. Okay. I'm gonna check right now. Nope. The 1.8 volts out. I also have no alright, I have 0.67. No one. Okay, so we have the enable signal. It's still not getting 1.8 volts out. Let's change our chip. That's my only guess. Let's change the chip. Where we have an enable, still not getting anything out. What do we have to lose by changing the chip? We have a donor board, we have a soldering iron, we have Hot air, why not just change the chip? So that's what I'm gonna do. And you know what, Brendan, what I'm scared about now is I saw my DC power supply spike to 26 volts when I first turned it on. So I hope the PCH isn't toast. It's okay. Pull this thing off first, or quick, nice and hot. I'm gonna move my drink over here so I don't knock it onto my laptop and then have to do component level repair on my laptop. I don't want to do that. If that were the case, what would probably happen is this laptop would go in a slot and I would go get the other ThinkPad used. Get our donor. First, let me clean the area. Let's get some leaded solder, feed it into the... I will miss my working distance, I will say that. I'm going to turn this board, it's kind of awkward to work on. Could get a Barlow lens, but my wick, which is somewhere right here. I don't need to trim that just yet. Does not have to be perfectly clean. Just somewhat clean. Hope it works out. So do I. That would be nice. Some flux. Some good flux, not the junk that's in the solder. Amtech flux works pretty good. I used MG Chemicals flux when I first started. I thought it was pretty good. Then I used Chip Quick, and that stuff was just terrible. And then I got Amtech, but I would say MG is nearly comparable to Amtech. I've never had an issue with MG Flux, but then again, that was a year ago. But I had no clue what I was doing. Alright. Not soldered yet, just set down. Need to line that up, but my error is too high. Need to kind of readjust the board. Still getting used to the new scope. But what I don't understand is the DC to DC controller may be bad, but what about our enable signal coming in? Why isn't that coming high? You know what I mean? Unless it's shorted internally from the chip. I don't understand. But you never know. Might work. Okay, let's plug this thing in. I like being able to move my scope out of the way. That was one thing with the other one that got me, is not being able to do that. Does not appear to be working. Come on. Prompt to boot one more time. Power button. Plug the Flux. And I just unplugged the power while I'm plugging the Flux, so plug it back in. Prompt to boot one more time. So let's flip it over. Let's measure our 1.8 volt rail again. Our CPU is getting warm, but not our PCH. Is the CPU warm because we were just soldering? Is the CPU warm because it's shorted to ground? Is the CPU warm because the fan is burned out and it's attempting to boot? It's just me being blind. Alright. I kind of smell burning board, but I don't know if it's from this. So 1.8 volt rail is measuring 0.2 volts. Wait a second. We have our enable signal from the PCH back. So we're onto something. Our enable signal from the PCH was there. Is my meter bugging out? It came back for a minute. I had half a volt there. No, it's not there. It's playing tricks on me. Yeah, I don't know. It's still not working, and we're still missing that signal. So, is this one a dead PCH? Should we move on? Yeah, it's soldered properly. Well, no, we're not getting any voltage. It's just my meter. What I noticed is if I touch my meter to the coating near the board, there's this coating. It measures voltage there somehow. But when I measure on the resistor, I get nothing. So I'm writing that off as EMI or something. I don't know. But we are getting nothing. So I'm gonna say this is a dead PCH. I'm not gonna waste my time on this. So here's what I'm gonna do. Let's put this back. I can't really put this in chat. I don't remember where I got that. So let's try and fix the beeping one. If I fix the beeping one, I can put that board in this. I don't know. The beeping one is probably the PCH too. So, since this is dead, not wasting my time on this. Wait a second, I can't use that as a donor. Do I want to fix this? You know what? It's the CPU. I don't think I want to fix this other one right now. So, I'm fairly confident that the one we're just looking at, this is a Inspiron 3521. Given the fact that this is coming from the CPU, it's really not worth my time. And here's the thing. This had corrosion right by the PCH, and I'm guessing. Now wait a second. If that's the case, since there's a corroded capacitor right by the crystal, the clock chip. Let's look closer at this. Since now we have a microscope that we can see. I wonder if a bad clock can cause that to be missing. Just like how PM Sleep S4L goes missing, I wonder if something bad in the clock circuit can cause that to go missing. And we have some nasty looking components right here. That does not, whatever it is, LH1, I'm gonna look this up. This does not look good at all. It looks like it's corroded and falling apart. And it's right by this other thing, and that other thing I know is the crystal for the PCH clock. Yeah, exactly. I'm actually not doing this for money. I'm doing it for learning. On this board, this one was in that Dell. This was for someone I knew, so I said, yeah, I'll get a new board for it. Got a new board, charge him $100, put it in, you know. This other one's for a local shop. I've had it here for months. You know, it's not a priority. It's just something, you know, yeah, I'll take a look at it, but I'm not gonna, no guarantees and no I can't tell you when I'm going to be able to fix it. It's if I have extra time. Right now my queue for MacBooks is nearly empty. I have more on the way, currently en route. I have this board right here. This is missing PM Sleep S4L. We're going to work on this on New Year's Eve, and hopefully we're going to get this fixed. This has no liquid damage. It is a 820 3208 or 3024, one of those. So this will make a fun project. Hopefully we can make this work. So one second here. So I'm hoping we can make this work on New Year's Eve. I'm planning to start streaming this at like 8 p.m. So it'll be like 11 Eastern time, and we'll see. So hopefully we can get that fixed. And then also I'm going to show you guys this right now. We are getting a brand new website, so I'll give you guys a sneak peek. This is gonna go live, well, it's already live now, but it's not public really. This is gonna go live public on January 1st. No, it looks pretty good in my opinion. I'll show you guys the other pages. I have a price list, you know. You guys can see this, I don't care. These are our new prices. And then I'll also added repair shopper tracking, so you can enter your ticket number and your last name and get a status update. And then our new mail and repair page. This looks pretty good in my opinion. I like the looks of this. It looks really clean. And contact us. And this will go live, you know. I don't know, this probably wouldn't be, there's only a couple people watching, so it's not really going to matter, and that's my business number, so what do I care? So yeah, until then, I'm not going to waste my time on this board. Next week we'll have a few repairs coming in, no, a bunch. One is going to be fun, one's going to be, I'll show you what we're going to be doing next week. I don't want to show the person's email address, but I'll save the picture. This is going to be one of our projects next week. So this is going to be one of many next week, and as you see, yeah, this looks really fun, doesn't it? Doesn't this look like it's just going to be a blast to do? Just solder a wire here, 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 and then whatever this is. I don't know how this happened. I really don't know how that happened. But yeah, this is going to be one of our projects next week. Then we'll have like 4 retinas to take a look at. 5 retinas, 4 retinas. And that's what's on the plan so far as of this week. You know, who's to say? You know, probably more will come in next week as well. So you know, it'll be a pretty busy week next week, and at least we'll have a microscope camera. We have a brand new microscope, and we're good to go. So on top of that, I think I'm going to call it quits. Thank you all for watching. No, it's for repair. It's at 820-2850. So thank you all for watching, and I will see you next time once I figure out how to close this.